Hey guys, Jay Auto Performance here. Alright. Just a warning up front. This is going to get a little technical and I'm going to do some complaining. So if you want to click off, go ahead. Alright, here's what I'm looking at here. Now this is a common thing, and I've been doing this for a long time. So in your AOD transmissions normally has a two-piece input shaft. It's got an inner and an outer, and this is how lockup functions and things. The popular modification of this transmission is to make it a single-piece input shaft, and the reason for doing this is to make it stronger. It does eliminate lockup, which on this particular unit you kind of have to do if it's anything with some power. Just the way it works, and I'll maybe go into that more in another video, but I did do a video on AOD torque converters previously that talked about checking the converter if it's a lockup or a non-lockup on an AOD, so wouldn't be a bad idea to go back and reference that video if you have time or interest in this. So what I'm going to talk about today is this world we live in now, everybody is either going out of business or choosing to go out of business. It's just everything's gotten so difficult in the last 3 years for people. So my point is, I used to buy these one-piece input shafts from a supplier that went out of business last year, unfortunately, and so now I'm having to buy things from, find alternatives. So one of the alternative here is Transgo makes a one-piece shaft, and it's a good quality piece, and there's a couple things I do like about it. So if you look at the instructions, they have you put a bushing in the end of the stator, which is good. Gives you better support. And that way you don't have to have a bushing inside the converter. So I like that. And let's see. And I don't have the shaft anymore. That job is already done and gone. And I don't really think I'm going to be buying another one. I've got another way of doing this. I'm going to go back to the way I used to do this. I don't know, 10, probably 15 years ago. So anyways, it's a two-piece deal. So you have the main shaft, and then it uses a stub shaft just like a AODE or 4R70W does. Okay, that's cool. I don't have a problem with that. One I used to have, we used to sell them too, but mainly I put them in the transmission. It was all one piece. The stub shaft was incorporated into the main shaft. So it was a little bit different than this. So okay, I like that. I'm fine with it. Here's the problem with this. So one thing I want to point out here about pressing this new shaft in. I did a video on this previously about pressing input shafts in straight and the right way. This one here, it doesn't have a lot of spline, and this is very subject to the problem I was telling you, that when you go and just press it in, it's not going to be straight. And this one in particular, being such a short set of spines, yeah, I had to go back on the lathe, and if you reference that video, I had to go back on the lathe 3 or 4 times to correct it. I got it nice and straight in the end. It came out really nice. It pressed in good, and the shaft's good quality. Not going to complain there, but you do have to utilize the method similar to what I did. There may be other ways of doing that as well, and maybe better ways, but that's how I do it, is with the lathe and the indicator, the dial indicator. So you can reference that video if you want. But anyway, so be careful pressing this in. So I like that, and I like going back the stub shaft. I think that's cool. Here's what I ran into. We're going to talk about the converter first, and this is where things get a little tricky. Okay, so here's the instruction sheet here. I hope I don't get sued, but we don't have any money left anyway, so go ahead. Run a C6 converter in an AOD! Exclamation point. Okay. Open converter performance, which basically means you don't have lockup. No more lugging third and fourth or coast down chug. Great for street rods and transplants. Works with custom high stall or stock C6 converter. I want you to remember that. It says it works with a stock C6 converter. Well, why do they say that? And why am I going to argue this? Because, okay, it uses the same splines as a C6 input shaft. So, yes, height-wise and the splines are all going to work from a C6 converter. That's all going to work. But here's the problem with that. And they do address this somewhat. Let's see. Alright, it's this page here. So, okay. Original C6 converter spacing, okay. While trans is out, position and push the converter firmly up against the flex plate. Converter pads must sit flush against the flex plate. If the converter rocks, the converter pilot has bottomed out in the crankshaft. Okay, good check, good advice to always do with everything. But here's what I'm getting at here. Why are they worried about this? Well, they're worried about this because a stock C6 converter, or aftermarket whatever, the pilot length is 1/4 of an inch longer than what the original AOD pilot length is. Okay, so you can't just put a C6 converter in here. Maybe you can. You know, if you do this check and your crank just happens to be bored that deep, well, okay, rock on. You know, we're good. But what they tell you to do, if you need to, basically if the pilot's too long and bottoms out into the crank is what's happening, because it's 1/4 of an inch longer than it should be, place a 1/16 to a 75 thou thick shim. Well, you don't have a lot of space on a stock stud. You could probably get by with one 1/16 inch shim. But here's the thing, okay, they tell you, okay, they show you here, see them measuring the height of the torque converter? So they're asking you to make the torque converter shorter than factory. This is shorter, okay, 5.825 to 5.885 is the required converter height. Have your converter supplier build one with these dimensions. So if you were going and buying an off-the-shelf C6 converter, or you have one or whatever, well, it's not going to work. They're already telling you to make it shorter in case you got to put this shim in. Because, you know, that clearance is going to come from somewhere. So, okay, that'll work, but be aware of this if you went and bought an off-the-shelf converter that's made to the factory height. Factory height is 5.937. So, you know, about a 1/16 of an inch taller. So if you go and put these shims in, you might still be okay, but, you know, with your pull-out, because you got to have your pull-out, but you may not. So, you know, we're kind of opened up a little bit of a can of worms here. Again, this will work, and I know I'm being critical, but I need you to be aware of this when you do this, and especially, you know, say you bought the transmission from somebody and you bought the converter somewhere else, and you know, the guy puts this this particular model shaft here. I won't say it. You know what it is. You saw the instructions. You know, you could have a compatibility problem. Another thing I want to say on these flex plates too. They do tell you about, you know, the AOD plate. Yeah, you definitely got to use the AOD plate, but they tell you, you know, the two different weights that are on it, and they tell you the diameter and the 164 tooth. Be aware also, I've seen a lot of AODs get destroyed this way. You can put a C6 plate on. It meets all the criteria that's in this literature, but what's different is the offset. It sits a quarter of an inch closer to the transmission. This is why the pilot is a quarter of an inch shorter, because the flex plate's more shallow. So they, you know, Ford designed it this way, so they knew that, okay, we got to make the pilot shorter because the flex plate sits closer to the block, and that's going to put the pilot in deeper into the crankshaft. So that's just a piece of information that's, you know, specific to Ford. One of the confusing things about Fords. So, okay, with all that out of the way, I want to get to what I really want to talk about here. And this is the kind of things you run into, you know, when you do something the first time. So I don't have that shaft to show you, and I don't want to buy another one. So let's just pretend this is the end of the shaft that comes in this kit, because this is just a C6 shaft I've got here. Basically the same thing. But what they did for your oil, so you gotta know this. Oil needs to come into the torque converter because, you know, oil is what actually drives your vehicle. It operates the torque converter. I'm sure you know that. But you got to fill the converter, but the oil also has to leave the converter. This is your lubrication circuit. This is your cooling circuit. So we want to get oil in the converter, and we want to get oil out of the converter. And we need to do this very efficiently. We want to have a lot of cooler flow and things like that to keep it cool, keep it lubricated. At the same time, we want to have the converter full. And we even ideally want to have some pressure in the converter. The pressure inside the torque converter affects the dynamics. You know, the more pressure you have, it creates more friction. There's a whole science behind all this I'm not going to get into today, but just know we want to have some pressure in the converter. That number is very controversial. And we don't want to have no pressure. We don't want to have low pressure. We don't want to have high pressure. What happens if there's high pressure in the converter? Well, the converter can balloon, and or what it does is it forces the converter out of the transmission pump, basically creating a hydraulic jack and putting a lot of extra forces on the thrust surface of the crankshaft. That's another video probably there talking about that. And so we don't want to build up excess pressure in here. We want the converter to leave. So normally what happens, and let me see, I think these instructions show, yeah. So if you look at your stator here, normally what happens is your oil enters between, you know, on the outside of this, between where your converter hub is, the oil enters between this space. Okay, just picture your converter hub here. Oil enters the converter through there, and then it leaves through the area where this bushing is and where the input shaft is. So normally there's no bushing here, so you have space between the input shaft and the stator, okay, and the oil leaves there. So what happens, they've put a bushing here, okay, and I like the bushing. And the bushing does not have any oil slots or anything in it, just in case you're wondering. But what they did to fix this, they drilled a hole in the center of the shaft, okay, goes down through. So say this would be your area where the bushing rides. So beyond this, they've cross-drilled another hole for the oil to get around the bushing. Excellent. I like it. Okay, that works. I didn't really calculate the size of the hole to see if it creates the pressure and flow that I like, but it looked adequate just by eye. So I didn't bother to actually measure square inches or anything on it, I'll be honest. So anyways, okay, all well and good. They've got this thought out. So when I first saw the shaft, I'm like, yeah, cool, okay. Well, I build the trans, I dyno the trans. Now, AODs are tricky to dyno for me because I have to hand control the TV gauge, and I have to watch the TV pressure, and then watch the other gauges and the tach and all that stuff. So I'm watching a lot of things, so it's kind of hard to watch my flow meter and also my pressure gauge on the cooling system. Well, what I noticed, yeah, oil flow is okay, not what it normally is, but, you know, not really super concerning. But I did also notice that, and honestly, like I said, because I was watching so many things, I wasn't really as fixed on that flow meter as I should have been. I didn't actually get a reading, and I regret that now, but I did watch catch the reading on the pressure gauge for the cooling system. So that was only about 20 pounds at the most. I normally have on this unit runs kind of high typically, between 60 to 80, certainly no less than 40. Unit worked good, everything was fine. So I said, okay, great. But you know, I was thinking about the pressure reading on the converter, and I says, that's kind of bugging me. And then it hit me. I says, well, wait a minute. We've changed the area where the oil leaves. We're going through the center of the shaft now. This is a problem. And let me show you the problem. So this is a billet cover, but typically your OEM converter has, you know, this is not attached to the turbine, okay? This is just a loose aftermarket hub, but it's basically a copy of a factory hub, and is, you know, very similar to any of your aftermarket converters as well. And the point I'm trying to make is this is the bearing surface here, and this does not have any oil slots or anything in it. And your factory converter uses just flat washers like this, and some of the aftermarket ones do too. So it just uses flat washers, might have one, might have two, whatever. Okay, this is the bearing surface that this goes up against. So I'm going to put this here. So I think you already see where I'm going with this. This and this. There's no oil slots. So the oil input shaft is in here, covering that up. Yeah, you'll get some leakage past the splines because they don't, it's not a press fit or anything. So some oil gets through there. Some oil will also squeeze through in between there, but okay. Have you figured it out yet? Where's our oil leaving the converter from? Down the center of the shaft. What have we done? We've blocked that hole in the center of the shaft. We've blocked this hole that's supposed to be on the end here. That's what we've done. Well, and they tell you, stock converter, no problem, exclamation point. Run a stock C6 converter. Well, it'll work. You'll get away with it. It's not what I want to see leave this shop, though. So what's the solution? Here's a solution. Very typical of what I have to do on lockup type converters is, you can see I've just milled slots. This allows the oil to get around the thrust washers or bearing. If you have a bearing here, it doesn't matter. Let me grab one of those bearings so you can see it, because you'll get a little bit more oil flow through a bearing than you will a flat washer like I just showed you, but not enough. Let me go grab a bearing for this. Okay, here's a typical bearing. This is a typical bearing that's used on damn near all of your aftermarket converters. And you can kind of see, I mean, you know, you're going to get oil through between these rollers, but not, you know, it's difficult. That's my point. So I just wanted you to see that. So anyways, what you got to do, if you're going to use this input shaft, again, not trying to tell you it's a piece of junk or anything like that. No, it's a good quality piece. But we do have to understand the oil flow. And a lot of converter builders, well, you know, in all fairness to a converter builder, they wouldn't know you've changed the location of where the oil flows out. So even if you had bought a converter from me, if you didn't tell me you put this input shaft in, I wouldn't normally put these slots here on an AOD. It doesn't normally need them. AODE or 4R70W I do, because that works differently. That has the oil actually enters the converter from the center of the shaft. So I do this on those if they happen to have a bearing or bushing here. Some of those just don't use one here in this clearance, so you don't have to do the slots. But anyways, so you got to do that. You need to cut your pilot down. Make your height factory as far as I'm concerned. And that's what'll fix this. So this is just something, you know, and another thing I'm going to complain about here, because I like to do that sometimes. You know, these customers that are just, when's my transfer going to be done? When's my transfer going to be done? When's my transfer going to be done? Shut the hell up and let me do my job. You know, this is irritating, guys. I'm trying to do a good job for you. And this is what I do. And this is something, you know, if I tell you, oh, it'll be done today, and then I realize this, oh, geez, I might even have to cut the damn converter open again or something. You know, maybe the converter was finished. And I was like, oh, no, I got to cut the converter. Well, I don't get paid for all that time. But I do want the job to go out right, and I will do it. But I want you to understand, this happens damn near every day, something. I'm always learning something, always discovering something. This is why we've got the test equipment. This is why I spend a lot of time learning these things. I want my stuff to go out and be hopefully better than the majority of what you're going to see out there. And that's my goal. I don't care about being fast. I wish I was. You know, that would really help us out financially if I could get these things out quicker. And nobody wants them out quicker than I do, or my partner for that matter. But first and foremost, I want it to go out right, at least to the best of my ability. Things still go wrong, unfortunately. That's just the nature of the beast, but taking the time to see these things and say, oh, okay, yeah, we got an issue here, we got to correct it. Well, this is, you know, you get held, or even, you know, you get held up like this on the last job, and that makes the next one a little later. So you're always falling behind schedule, and you're typically falling behind schedule because you're trying to do a good job. And if, you know, who doesn't want somebody to do a good job, you know? I know we all want it fast. You know, like these car shows that drive me crazy. You know, they get this car in, they got to restore, and, you know, the big drama. Oh, geez, you know, we didn't know it was this rusty, or, oh, we didn't know we were going to have to rebuild the motor, and the customer wants the car done in 3 weeks. And we're making custom fenders and a new roof, and somehow they're getting all this done in 3 weeks. Yeah, whatever. Maybe 3 years. And then, the big man comes in a couple of days into the build and says, oh, sorry, guys, bad news. The customer needs it a week earlier because he's got another auction or car show he wants to make. So I just cut a week off of the times, and we got to be done in 2 weeks. But geez, big boss, we found all these other problems. Yeah, well, we got to get it done. Got to make the customer happy. Yeah, okay. That is not what you would call reality TV. And I know you guys know these shows. They're ridiculous. I hardly get a transmission done in a week. Never mind restore a car. But anyways, I shouldn't complain. So just had to get that off my chest, because every time I have to change a vendor or something, this is what I gotta go through. But I probably won't be going back to this. I'm gonna go back to my method I did probably, I think it was 15 years ago. I don't even know. Because the problem is, if, a lot of people, they might buy a transmission from me, and they may not buy the converter from me. Well, if I build them an AOD with this shaft, and they have a converter from somewhere else, it's probably not going to flow right. And that's going to reflect poorly on my unit. And I don't need that. So, if I'm building the converter, no problem, I can address it like I showed you, and, we're in good shape. But, I think a lot of people, they build these things and they don't realize this stuff. They think, oh, well, the engineering has been done for me by the company that made the shaft. There's also another issue with this shaft, too. I think I'm going to cover that in a separate video. I've kind of gone over my time limit here on this one, so I'll do another video on this. I'll make a part 2 on this one. So anyways, I could do probably several videos on oil flow through the converter. And I learned this from a friend of mine, John Goebel, who has Goebel transmissions out here in Waco, Texas, and very smart guy. Just builds some just badass transmissions. I mean, he understands things like this, and he just builds some cool stuff. And I've learned a lot from him, so I gotta give him credit for that, because he showed me this many years ago when I first got into building converters, about, talking about, man, you need to understand the oil flow in and out. And there's a whole science to how much you in, how much out you want. And he's a guy who spent a lot on that and shared that knowledge. A very kind man to share that knowledge with me. And it's, came useful on this job, that's for sure. It's come useful on a lot of jobs. So I just want to point that out, and again, I'm not trying to give these guys a bad name. It's a really good kit, and I do really like the bushing in here, and it's quality stuff, but it's got a couple of flaws. I'm going to go over another one in another video, but it's very doable, and there's nothing else out there anymore, I don't think. So I don't know, we just got to make these things work for us. But that's that's hot rodding, that's aftermarket parts. You got to be creative, you got to know what you're doing. Just like if you buy a door skin for a Mustang, and you're not expecting to have to grind it or tweak it a little bit to get it to fit right. Well, that's just unreasonable. You just have to be good at body work and know how to make that thing fit. So transmission building can be like that as well. So anyways, I apologize. I went over and probably complained too much. So anyways, we'll see you on the next one. Thanks for watching.